About our company, PaiSat is a leading satellite operation and application service provider in China since 2008. And we are one of the first batch of the listed enterprises in the STAR Board of Shanghai stock market. PaiSat has independently developed the Pixel Information Expert, or PIE for short, the remote sensing software with our own intellectual property, and it is the very first. And we also developed the very first remote sensing cloud service platform in China. We name it as Pi Engine, which is also going to be the focus later on today. So with Pi Pixel Information Expert software series and Pi Engine, we have realized the independent research and development of basic remote sensing software in China. PaiSat has established an overseas subsidiaries in Hong Kong, in Sydney, in London, Geneva, and also many other cities all around the world. And we have now been providing spatial application solutions for government sectors, for universities, for research institutes, and enterprises and small companies. So in this introduction to the company is going to be, I'm going to bifurcate it into three parts. So the first, I will give you more on the profile of the company. As you can see on this business layout of PaiSat in 2022, we are, as I mentioned, we are one of the leading satellite operation and application service provider in China since 2008, and we are headquartered in Beijing. We have 6 established international subsidiaries, 4 research and development centers all around the country. We have more than 15 business departments for industry applications, and now more than 100 branch offices all around the world. So our company was established in 2008, and in 2009 we independently developed the flagship software we named Pi for remote sensing image processing, and also listed. We went listed on the Shanghai Science and Technology Innovation Board in 2009. The company now has more than 4,000 employees, in which over 80% of them are technicians. And in terms of the qualifications and certificates, we have the ISO 9001 quality system certification. We are one of the CMMI level 5 company. We're also one of the company has the system integration level 4 degree, and also in Chinese market we are the class A serving and mapping qualification owned company. And in the next part, I will give you more on the core strengths of our company, and I'm going to focus more on the Pi software series and our Pi Engine remote sensing cloud service platform, and also another one which is about the STAR satellite constellation we are going to launch. So we can bifurcate our business scope into 3 product lines. The first is about the spatial infrastructure planning and construction, in which we provide initial planning and fundamental infrastructure planning and feasibility analysis, and those kind of project design and the consultation service, such as we have participated in the high resolution Earth observation system construction in China, and we also participated in the civil spatial infrastructure planning projects, and one of the major service provider and designer in the Beidou navigation system. And the second product line is about the Pi software and its industrial solutions. So this Pi software series has been widely applied in many industries, such as natural resource, ecological environment, emergency management, meteorology, hydrology, and so on. And the third one, which is also a newly emerged product line is about our cloud services, which is led by our remote sensing cloud service platform named PyEngine. And also it derived into many other aspects, such as we have SaaS platform for air pollution monitoring, for smart agriculture, for water conservancy, for forest resource management, for fire monitoring, and so on. So this gives you more about the spatial infrastructure planning and the construction projects that we have participated. Up next is the Pixel Information Expert, which is our flagship software product for remote sensing data and processing, which is also going to be the focus for today's training. I'm going to, in the first half in the morning, I'm going to give you a more in-depth introduction to the basic module in this software. We named it PyBasic. And in the afternoon, I will share more time on PyAuthor. Like PyAuthor is for large-scale remote satellite image processing, and we have more modules in this software series. Like we have PySAR for SAR image processing, PyHype for hyperspectral image data processing, and PyUAV for specifically for UAV data processing. And in other terms, we have the PyScience, which is the scale set image analysis software. And we have PyAI, which provides integrated AI interpretation capability, and that is also integrated into the entire software series. And finally, we have PyMap for 2D and 3D visualization, and model rendering for large-scale scenes. And above all, we also have the PySDK, which is for the secondary development kit for users to create their own applications based on Py software. And also we have the PyEngine, which is the cloud version, but it comes with more, not just remote sensing data processing, but more kind of services. So PyEngine is the integrated remote sensing image processing technology and that we created, and it integrates integrating cloud computing, AI, and other IT technology to provide, we call it the one-stop remote sensing services for users. It has advantages such as it is capable of being high efficiency, low threshold, especially useful for beginners. It is low cost and easy to access. So with the help of this platform, it provides users to have access to remote sensing data processing, from data acquisition to data storage, data processing and computing. And finally, you can manipulate the data and do some professional analysis, do some decision making, and finally generate your own product. And also the platform enable you to publish and share with the others. So the fundamental goal of creating this platform is we want to make the remote sensing data processing available on cloud at all the time, and also to remove the barrier for normal users and users who don't necessarily have the professionals or very fancy equipment can also easily use this platform to do some remote sensing data processing. As you can see, it helps to remove the barrier between the data and the application, between remote sensing data, which is generally speaking difficult for non-general users to have access to, and also we have inbuilt mature industrial applications or modules that users can easily have access to and to have their own results generated. So this platform can do a lot and can solve the general or professional requirements for the public, for research institute, for industrial, for educational purpose, for governance, and for anyone. So as you can see, we have the fundamental goal, which is to make remote sensing available anywhere at any time. So up next is the about the star constellation we are going to launch. We name it PISAT-01. So PISAT-01 is the very first InStar satellite constellation in China. It will play an important role in high precision surveying, deformation detection, and many other areas, making a great contribution to the application of the SAR data. You can see that it's going to be the very first launched 1+3, which means one master or main satellite and 3 auxiliary satellites that forms a constellation. It's going to be the very first 1+3 formation SAR satellite constellation launched in China. And in terms of the key technical specifications, as you can see, this constellation is going to serve in X-band with a central frequency at 9.6 gigahertz. Its spatial resolution can go up to 0.5 meters per scene, and the width of the picture taken per scene can go up to 80 kilometers in radius. So this constellation is going to be controlled by the PyEngine platform, which will fully support the cloud operation for this satellite constellation and provide customers with services in the fastest, smartest, and the most convenient way. So this is the schedule of the launch of this satellite. We're going to launch the constellation in late 2022 and complete the on-orbit delivery in 2023. Up next, I'll move to more introduction about our industrial solutions. So throughout years of accumulation in remote sensing data processing and its application in multiple areas, we have accumulated a lot in these sectors, such as in natural resource. We can perform the natural resource monitoring. We can perform the land security and monitoring. And in meteorology, we can do the precise meteorological forecast, the extreme weather warning. And in marine application, we are capable of providing services in marine ecological monitoring, in island and coastal monitoring, and so on. And that also applies for the water management area, for the emergency management, for ecological environment monitoring and control, for Beidou navigation, for smart agriculture, for drone applications, land resource, and also technical or engineering consultation and planning, and more. So I'll pick some of the examples to illustrate to you. So that you can see the first one is about the natural resource application. The examples on the left shows what we can achieve in the farmland protection using remote sensing monitoring technology. And on the right, it shows that for the monitoring of natural resource. And the other example on the left is the project we have been working on, which is named the Real 3D China project, which is based on the 3D rendering technology and the aerial photography technology to build in real time 3D models for urban planning and construction, and provide multiple layers of services and support the business development, such as in smart city planning and urban management, and so on. Up next is another example we have established in meteorological big data cloud platform. So the picture shows the meteorological center that we designed for a lot of provincial bureaus in China, which allows the governors to take decision-making suggestions, and it helps to from data collection for meteorological data collection, data processing, data storage, and finally output used for services in terms of meteorological like weather forecast or extreme weather prediction, and have the information displayed on the large screen and monitor monitor the weather at all times. Up next is another example we have in smart agriculture. We name it the Pi Landscape platform. So this platform relies on the industry-leading technologies such as big data analysis, artificial intelligence, cloud services, and it is also supported by the remote sensing image-related analysis algorithms. This Pi Landscape can provide agricultural big data services with a cloud plus local pattern, and also the data is based on from space, which means satellites, and from air, which can mean from aircraft or UAVs, and also from ground-based integration. This platform focuses on the needs of different users and helps to save costs and increase the efficiency in agricultural production, and supports the regulation and control of the industry, and promotes the transformation from conventional to a more smart and modern pattern for agriculture. Up next, we have the forest fire remote sensing monitoring platform, which can help to provide forest fire monitoring information, and which is mostly based on the meteorological satellite. And it provides the information such as the fire spot location, the area of fire, the temperature of fire, and also weather information such as the temperature, the precipitation, wind direction, wind speed, and many other factors, which is very closely related to the happening of forest fire. And also the service can be, the warning information can be pushed through mobile apps, through media accounts, or messages, or emails. Another example in terms of the air pollution remote sensing monitoring, we can use this platform to monitor the air pollution, and it can be used to monitor like air pollution, hotspot grid, and for the concentration of major factors in the atmosphere, such as the PM2.5 and PM10, and also the overall accuracy of the PM particle concentration prediction can go up to 90%. And up next is another example in water conservancy in water management area, which is for the black and odorous water remote sensing monitoring. And this parameter can be monitored once a month and provide parameters like the location, the degree of degradation of the water bodies. And up next is another example using drone technology, which is used for the municipal waste remote sensing monitoring. We can use drones, use UAVs to monitor the location, the area, township, and type of different type of waste, especially domestic waste and municipal waste. And the overall accuracy of this platform is above 85%. So these are some of the very useful examples, or we call it the SaaS solutions, that we provide for different industries, and all of them are also based on Pi Pi software, and we integrate them into a different SaaS platform. So up next, I will spend more time on the focus of today's some introduction to the Pi software series. So throughout years of development in remote sensing satellite and remote sensing data processing areas, we can see that there's a huge improvement in the types, in the volumes of remote sensing data, and that allows us to do more and more throughout the days. So it has become a problem for users, especially general users who how to have access to the remote sensing data and how to have them easily processed to get what they want. So we take the potential of data to serve the industry as our major goal to develop in this industry. We have PiSat has developed the Pixel Information Expert software series to activate the value inside the remote sensing data and to serve in the industries. And we have come up with the Pi series, the Pixel Information Software series. So this series has now reached to a 6.0 version or 6.3 versions for all the modules. And we also have a very complete software series layout. And in terms of the functional modules, we can the Pi series can process optical data, visible light data, SAR, hyperspectral, drone, and many other heterogeneous data with a full workload processing capability. And in terms of the formation of the product, we not just have the desktop version, the Pi software series, but we also integrate all of these technologies that we have accumulated into and combine that with cloud computing technology and created the Pi Engine platform, which is majorly facing the remote sensing data services for natural resource, for ecological environment, and many other areas. So now, as you can see on the screen, we have the in terms of the desktop version Pi software, we have the Pi Basic, which is the fundamental being in the software series, and also the most recommended module for users to begin with. And other than that, we have the Pi Author for satellite image processing, especially in a large scale. We also have the Pi SAR, HYPE, and the UAV individually for SAR, hyperspectral, and drone data. And Pi SAS, which is for the scale set image analysis, and Pi AI, which is integrated into the software series and to provide artificial intelligence interpretation capability. And we also have the Pi Map, which is for the 2D and 3D visualization system for large-scale scenes. And above that, we have the Pi SDK, the secondary development toolkit for users to build their own module based on the Pi software, and also the Pi Engine, the cloud version, the cloud service platform. So some of the new characteristics of the latest version of Pi software, including it is capable of providing rapid processing of massive remote sensing images. It is able to provide automatic generation and the joint adjustment of large-scale multi-source data. It is capable of providing hyperspectral image processing capability, which is based on harmonic analysis. It the AI interpretation algorithm is integrated, and the remote sensing image detection of rapid change can be achieved. And finally, it comes with PyMap, which can allow users to perform the 2D and the 3D visualization for image rendering, for modeling, for large-scale scenes. And up next, I will focus on some of the major modules and give you more information about what they are capable of doing for serving the users. The first is the PyAuthor, which is the efficient data processing software for large area images. And also, it's going to be the focus we are going to work further on later today. So the PyAuthor provides efficient data processing solutions for large area images using the desktop or the clustered version software. And some of its major characteristics, including that in the data processing process, the data will not be locally stored during the whole process, which can save the disk storage on your computer, but also to allow users to review, to display the process results in real time. So this PyAuthor module has been serving more than 50 industries, and it is also compatible with more than 40 types of global mainstream sensors or satellite images. Some of its correct characteristics, such as that data will not be locally stored during the whole process, and it has very excellent human-computer interaction capability especially for dealing with massive data. And at the bottom, you can see some matching processing for different types of data. Up next is PySAR, which is a SAR image processing software. It has the characteristics such as it provides a full workflow in SAR processing. It is capable of providing automatic and accurate clock adjustment, performance, and so on. It is also very accurate, provide accurate extraction of target features, and you can see some typical applications are displayed on the screen. It can be widely applied in many areas, such as for water extraction, for land use and land cover change detection, for coastline detection, for ship detection above the ocean, and also recognize a lot of ground features. Up next is the Pi hyperspectral data processing software. It provides the whole process of fast production for hyperspectral image. Some of its characteristics, including it combines the spectral spatial image fusion method, which is the high accuracy for spectral information. And it is very accurate and efficient in terms of the atmospheric correction. And it also comes with a library which supports query analysis and applications. Up next is the PyUEV, which is for drone data processing. This PyUEV integrates the SFM, the struct from motion technology, and combine that with the aerial photogrammetry technology to achieve the automatic data processing for either unmanned aerial vehicle or manned aerial vehicle that allows to have very efficient and intelligent data processing capability. And also it assures a very high accuracy in the aerial photogrammetry data processing. So Up next is the PyScience, which is a scale set image analysis software. It can realize the one-stop image, especially semantic image producing capability that it starts from the image segmentation, sample selection, and you can either do that manually or automatically, and to the automatic classification of image and change detection, and finally to achieve the semantic mapping capability. And this process can be used for recognizing ground features like road, like water bodies, farmland, buildings, and forests, and many others. So some of the examples, such as that shows for the semi-automatic intelligent interactive extraction using the Magic Wand tools. And up next is the PyAI, the intelligent interpretation algorithm for remote sensing image processing. So compare with the traditional image or ground feature extraction maneuvers, which is normally operated by human. This new technology based on AI interpretation is much more faster and mature, especially for dealing with the automatic target extraction at a very large scale, at a very wide range, at a very high frequency, and do the multi-objects at the same time. And this can be applied to recognizing a lot of ground objects, like for aircrafts, for airports, for greenhouse, for playground, and many other types of ground features. And finally, we have the PyMap, which is a efficient 2D and 3D interactive displaying software that can be especially used for massive data rendering, for large scale rendering and displaying. Up next is the PyEngine. We have mentioned previously, which is based on the fundamental requirements proposed by the users. We have built this platform that can allow users to start from data storage, data management, data distribution, and application, and data processing, and finally to achieve some of their own data applied products, and finally have the outcomes distributed and shared with all the others. Up next are some industrial applications in different industries. Like in land use industry, we can use Pi software to perform land survey, land use change detection, exploration of geological and mineral resources, and so on. And in terms of environmental monitoring, we can use Pi software to monitor air quality and water quality, and the black and Ardos water monitoring, and also monitoring and identification of drain outlets. And also, as I had previously mentioned, some of the SaaS solutions that we have created, all of them are derivative from Pi software, which means you can theoretically you can do the same with just using the Pi software. And up next, for meteorology monitoring, we can use Pi software to monitor and assess climate, and to monitor marine environment, to monitor marine resource, and also disasters. And in water conservancy area, we can use Pi software to monitor flood disasters, to monitor forest fire, and such as landslide and debris flow and monitoring, and also provide critical warning information to governors and also to users who are concerned about these kind of natural disasters. And also in terms of agriculture, we can use Pi software to monitor the growing status of the crop and monitor agricultural disasters and monitor agricultural resources, and combining all of them, that can provide very valuable decision making or decision solutions to not just normal farmers, normal users, but also to the governors at a bigger level, at an upper level. Okay, so this is a quick general introduction to the software series of Pi software. Up next, I will move on to the first focus, the actual focus for today's Pi Basic. But before that, I would like to give you more instructions on today's training. So in today's training, we are going to provide training lessons for two of the modules, which is about Pi Basic and Pi Author. And also we are going to give examples, if time allows, give you examples and provide you with sample data and also the training, the software itself, to help you to do the same and have a try inside the software itself. So later on, I will share this document to all of you who have signed up and participated in today's training. And this document includes all the instructions you need to know to on how to use the data and how to download, first how you can download and have access to the training package. And you will learn more about the system requirements for your computers. And it will give you more information like how to have the software installed and how to ask for training licenses. And if you have go through all the steps, and you will find out if you are in need of the license to the software, PiSet will give you trial license and help you to have a test, have a go on in the software itself. And also it gives you more instructions like for the frequently asked questions in the software using. And if you have further questions, you can ask for technical support. And all of those information are in this document. Okay, so for the Pi Basic software, I'm going to use a video which can help you to have a quick understanding of what we can do and what we are going to achieve, especially in the operational part.
Hello everyone. Today I'm going to introduce how to get a quick start for Pi Basic. So here are the contents for today. We have 4 parts. The first is software overview. Second is operation interface description. The third is functional module. And the last one is toolbar. Okay, and let's get started with the first part, the software overview. Pi Basic Remote Sensing Image Processing software is one of the Pi series software for professional application products. Here the Pi, PIE, stand for Pixel Information Expert. This software provides general remote sensing image rendering, spatial data processing, analysis, and mapping plugin to ensure the underlying platform, availability, stability, and efficiency of common functions. It can provide various functions, including data display and browsing, data processing, extraction and analysis of monitoring products to make integrated solution for thematic chart generation. It is mainly for teaching and scientific research applications in schools and for scientific research institutes. It can also provide convenient image processing tools for users from different industry sectors. Here we have these 6 features about this software. They are fast reading and rendering of multi-source data, integration of remote sensing edges, rich and practical basic processing tool set, convenient thematic mapping ability, excellent Chinese satellite support capability, and the last one, support multi-source data format. So for fast reading and multi-source data rendering, PyBasic has clear data structure and management flow, which can manage all the data easily and clearly and provide integrate multiple network map services. It is known that almost every software's work speed depends on the device configuration. But for PyBasic, it can process fast loading of big data and smooth roaming and zooming with a fair device configuration, meaning that you can use this type of device to complete the processing of PyBasic. And since we are a Chinese company, so that our clients are mainly from Chinese universities, companies, and governments, therefore, PyBasic has an excellent Chinese satellite support capability that can support all these satellite data. PyBasic also has integration of remote sensing and GIS ability, which means that it provides a rich industry GIS symbol library and a secondary development interface for remote sensing and GIS processing functions. Here are the rich and practical basic processing toolset of PyBasic, and I will introduce these tools later. PyBasic also has convenient thematic mapping ability, and here are some examples which were completed by using PyBasic. By using PyBasic, for examples, we can do estimation of forest volume. In this case, the time interval between those two images is 5 years, and we use PyBasic based on the Spot 5 data and small class data in 5 years, which can provide an important reference for the estimation of narrow class volume of local tree species in groups. Our software is also used in forest disaster monitoring. Like in this case, this is applied to forest disaster monitoring in an area. We can clearly see that the forest fire risk in this area can be clearly identified through our software, and the current vegetation area of the area is accurately reflected. For example, in this image, the forest after is marked in red, the bare land is marked in yellow, and the vegetation is marked in gray. With the support of this data processed by our software, our clients can accurately and clearly understand the on-site situation and provide decision support for planning the restoration and the construction of burned areas. Here's another example. By using PyBasic, we can also do automatic extraction of new construction land and building change detection. So here is another instance of similar building change detection. We can see that our software extracts the differences between the buildings in the two images through the remote sensing image data of the same area, before and after, and marks them with pink boxes. From another case, we can see the outline frame of the detected building area. Also, the comparison between those two remote sensing images in this same area. We can see that there are many buildings with red or blue roofs in the remote sensing image in front of us. But in the remote sensing image in the back, our place with buildings has become an open space. This shows that from the front image to the back image, the buildings detected in this place have been demolished as a whole. However, our software can accurately identify these places and mark them with orange boxes. Next is part 2, Operation Interface Description. PyBasic adopts Microsoft Ribbon style with beautiful interface with mainly 7 parts. Title bar here displays the name and the version of PyBasic. The toolbar displays all functional modules of PyBasic. The layer management bar manages the layers which is loaded into the software, including map activation and deletion, loading of layers, delete and display, control and modify coordinate system, etc. The normal toolbar displays common functions of PySoftware data browsing. Main view area displays the data processing progress and results after processing. View toggle button controls switching between data view and drafting view. The status bar displays real-time parameter information of data status, such as coordinate system type, scale, map coordinates, and screen coordinates of the main view. Next is part 3, Functional Module. In this part, I will introduce main functions of PyBasic. The first is the system, on which users can manage maps, including creating new map, open and save map in different formats, system properties, and system exit function. Then is the common functions. It includes data management, map browsing, information viewing, spatial measurement, project area setup, and edit. The third is the display control system. It displays control including brightness enhancement, contrast enhancement, transparency enhancement, stretching enhancement, brightness inverse, transparent value reset. Then is the image pre-processing, which makes a series of corrections to the original image and improve the data quality to make it meet the requirements of image interpretation. Image processing. Image processing includes image classification, image transformation, image filtering, edge enhancement. Then is the basic tools, providing some necessary tools for image processing placed in the basic tool module. The next one is comprehensive interpretation. This function is mainly used for visual interpretation of image data. It includes dimension plotting, menu information extraction, and font setting. Then is the vector processing. It is mainly used for image vectorization. The next one is the monitoring analysis. It is an automatic feature extraction or change detection, which can be done for some industries. Generally, multispectral data from 4 bands: blue, green, red, and near-infrared are used. Next one is thematic mapping. Thematic mapping is the process of generating a map product. Users can quickly add scale bar, title, north arrow, and other objects to the image to generate an exportable map. Process customization is the workflow used to create, edit, and manage a series of tools. Users can use the process customization function to create own geoprocessing model and execute this model to complete data processing. View provides the functions of view management and software interface style settings. The last one is the help function. Provides the functions of viewing algorithm board, user menu, version information, and common shortcut keys. The last part is the toolbar. For toolbar, common toolbars are set on the main interface of PyBasic to display common functions of software data browsing. Here it has pull frame zoom in, means can pull and zoom in all layers under the current map. Pull frame zoom out means can zoom out all layers under the current map. Center amplification. It can zoom in the center of all layers under the current map. Center reduction. It can zoom out the center of all layers under the current map. Roam means can pan and roam through all layers under the current map. Full image means all layers under the current map can be displayed in the view. One-to-one display means the current layer can be displayed in a one-to-one manner, meaning 1 pixel of the screen represents 1 pixel of the layer. Roller shooter means users can press and hold the left mouse button in the view to move up, down, left, and right to realize the rolling shooter effect of the upper image. Prop tool, it is mainly used to query the pixel information of grid data. Property query, query the attribute information of vector data. Spatial measurement means distance measurement, area measurement, object measurement, updating and measurement unit can be carried out. Copy means can copy selected vector features. Cut means can cut selected vector features. Paste means can paste vector features that have been copied or not. Delete means can delete selected vector features. Cancel means can go back to the previous operation state. Restore means after clicking cancel, users can also click restore to rebuild the current state. Next, we are going to have a quick understanding of today's work. First, when we get a raster data, we need to do radiometric calibration. So, what is radiometric calibration and why we need to do it at the beginning? Generally speaking, radiometric calibration is divided into absolute radiometric calibration and relative radiometric calibration. Since we know the difference between these two kinds, or we're familiar with these two kinds, absolute and relative. But what do absolute and relative stand for in this scenario? So in this case, absolute radiometric calibration is to establish the quantitative mathematical relationship between the spectral radiance value at the entrance pupil of the imaging spectrometer and the digital quantization DN value output by the imaging spectrometer in different spectral bands through various standard radiation sources, so as to eliminate the error generated by the sensor itself. On the other side, the relative radiation calibration is to correct the unevenness of the detection components, to eliminate the inconsistency of response of detection components, and normalize the original brightness value, so that the corresponding output pixel values of pixels with the same incoming radiation are also consistent. The result of relative radiometric calibration is still a dimensionless DN value. Because we are about to use absolute radiometric calibration today, so next thing is to learn a little more about it. Here are the two formulae of absolute radiometric calibration. The first formula can be used to convert the channel observation DN value of each satellite load into the equivalent apparent radiance data at the entrance pupil of the satellite load. You can have a quick look at the formula. The lambda is the radiant energy value of the ground object at the top of the atmosphere. Gain here is the calibration slope. DN is the satellite load observation value. Bias is the calibration intercept. With lambda is the radiant energy value of the ground object at the top of the atmosphere. The apparent reflectivity can be calculated by the second formula here. ESUN stands for solar spectral radiation. D is solar terrestrial distance parameter. Theta is solar zenith angle. So that the radiation calibration function of pi basic can support such varieties of satellite data. Because today we are going to use GF1's data, which is also the type one of the satellites data supported mentioned before. So here I give you guys a quick introduction of GF1. GF1 satellite is the first satellite of China's high-resolution Earth observation system. GF1 satellite was successfully launched on April 26, 2013. GF1 satellite is equipped with 2 meters resolution panchromatic, 8 meters resolution multispectral cameras, and 4 16 meters resolution multispectral cameras. It breaks through key technologies such as high spatial resolution, multispectral and wide coverage cameras, and combined optical remote sensing, with a design life of 5 to 8 years. Okay, after the knowledge on radiometric calibration, we are going to undertake an atmospheric correction. So why we need to do it? because when electromagnetic waves are transmitted in the atmosphere, the scattering of atmospheric molecules and aerosols and the absorption of ozone, water vapor, and other gases will affect the signals received by the sensor, resulting in the information received by the sensor cannot truly reflect the characteristics of the Earth's surface. In order to obtain the accurate information of the surface, we must eliminate the atmospheric influence as much as possible. The purpose of atmospheric correction is to convert the calibrated apparent reflectance of the obtained remote sensing data into the surface reflectance that can reflect the real information of the surface features. Just like radiometric calibration, atmospheric correction is also divided into two types of absolute atmospheric correction and relative atmospheric correction. So, the absolute atmospheric correction is the method of converting the DM value of a remote sensing image into surface reflectance, surface emissivity, and the surface temperature. It always using MODTRAN model, ATCOR model, or 6S model. These three types of models. Now let's have a quick look at the three types of models. The first is the MODTRAN, which is a software package for calculating atmospheric transmittance and radiation developed by the Geophysical Laboratory of the U.S. Air Force. It is developed from LOTRAN. It improves the spectral resolution of LOTRAN. The parameters to be input in the calculation of the model include satellite sensor parameters, atmospheric parameters, observation conditions, and surface parameters. The calculation process is complex. The second is the AQUAR model. AQUAR model is an additional module of atmospheric correction under ERDAS, which is used to correct the change of spectral reflection of ground objects of the Earth's surface and remove thin clouds and haze. AQUAR 2 carries out atmospheric correction in two-dimensional form, which is suitable for images of flat maps. AQUAR 3 is a model for atmospheric correction of mountain images launched by ERDS image, which requires DM data corresponding to the image area. The last one is 6S model. 6S model can well stimulate the atmospheric influence of solar electromagnetic wave in the transmission process of sun ground target sensor. Compared with 5S model, 6S model considers the altitude of ground targets, non-Lambertian plan, and the new types of observed gases. 6S model observes the latest scattering calculation method, which improves the scattering calculation accuracy in solar spectral band compared with 5S. The relative atmospheric correction can be regarded as the mathematical model. Input the numbers fitted under a particular scenario and then output the ideal module accordingly. The result does not consider the actual reflectance of the surface, like what absolute atmospheric correction does, and always using internal average method or flat field method. The atmospheric correction function of PyBasic software is based on 6S atmospheric radioactive transfer model and can realize atmospheric correction for the variety of satellite data. If the data needs high precision quantitative remote sensing application, that is, the application with high standards for atmospheric correction accuracy, atmospheric correction must be carried out to obtain the real surface reflectance. After radiometric calibration and atmospheric correction, we will be going to do orthorectifications. Orthorectification is the process of image space correction and the geometric distortion to generate multi-center projection plane orthophoto image. It can not only correct the geometric distortion caused by general system factors, but also eliminate the geometric distortion caused by terrain. From the implementation process, orthorectification refers to the geometric correction of the original image by using ephemeris parameters, an appropriate number of control points, and DEM through strict physical model or rational polynomial model to eliminate the deformation caused by external orientation elements of the camera and the topographic relief. After orthorectification, your data will have these mirrors. First, high accuracy and can meet the needs of remote sensing mapping and base map updating. Second, ensure the accuracy of a geographic location of the same image in different sensors, different spectrum ranges, and simultaneously interpreting time. It can carry out computer automatic classification, change monitoring of ground feature characteristics, and other application processing. Third, analyze the image information and make various remote sensing thematic maps that meet the requirements of measurement and positioning. After radiometric calibration, atmospheric correction, and orthorectification, next we will undertake band operation. Because we will be going to do vegetation extraction, so we must do normalized difference vegetation index calculation. This is the formula. And where NIR is the reflection value in the near infrared band, and R is the reflection value in the red band. Because remote sensing images are processed excessively, and most of the images are in the regular square format. In remote sensing image research, it is mostly carried out in specific areas. For example, studying remote sensing images of LA. If images are outside LA, they will have no mirrored for researchers. If the whole image is analyzed and processed instead of cutting, it will increase a lot of unnecessary work, which is time-consuming and a waste of resources. Remote sensing image research is mostly carried out for specific areas. Its purpose is to obtain the selected image range area and prepare for subsequent image processing and analysis. For remote sensing data processing, when the research area is smaller than the single image, cutting first and then processing. Follow those two steps will save a lot of computing time. Because of that, therefore, after the NDVI calculation, we must cut the research from our data, so we need to do image clipping. Image clipping refers to removing the interested area out of the research area. Its purpose is to obtain the selected image range area and prepare for subsequent image processing and analysis. After all these steps, we can finally calculate the vegetation area and undertake extraction. The histogram statistical function of PyBasic is used to calculate the vegetation area. The pixel with pixel value of 1 is vegetation area pixel. Move the slider under the histogram to the place with pixel value of 1 to display the number of pixels with pixel value of 1. An GF1 image has a spatial resolution of 16 meters, and a single pixel area is the number of pixels in the vegetation area. Finally, it is the image rendering tool, which is used to render the vegetation area data to form a thematic information display diagram. Alright, the contents I mentioned before are mainly the academic knowledge and the theories behind the PyBasic. So now let's take a 10 minutes break before.
Okay, so that's what you need to know. What you need to know to get started with using PyBasic, and also the process of how to use PyBasic to perform an NTVI calculation so that you can do the vegetation extraction. I think it's lunch break time, so this is all we have for the first part in the mornings, and due to the limited time we have today, we don't have time to do the actual operation in PyBasic, but you will find more useful information